of the areas of quantum mechanics that I find fascinating is how quantum mechanics relates to reason, logic, and rationality. And to unpackage this question, we've invited Dr. Erica Carlson to speak with us. Erica, I gave a talk one time about the laws of logic, particularly the law of non-contradiction. Aristotle said nothing can both be and not be at the same time and in the same way. A cannot equal A and non-A. I had a physicist in the audience, and he said, wait a second here. What about quantum mechanics? I mean, couldn't light appear as a wave and a particle at the same time? What does quantum mechanics do to maybe some of these principles of logic and reasoning? Are we misunderstanding something there?
That's a great question. So when you first started talking about, the law of non-contradiction and how it might play into quantum mechanics, being a physicist who's well-trained in quantum mechanics and, teaches it to others, and I'm familiar with all the equations, math can't be self-contradictory, right? So in our mind, the grounding of it is all this beautiful mathematics, which if we had a couple of years together, I could teach you too. It's not impenetrable. It just takes some time and effort. But mathematics, cannot be self-contradictory, right? It is in the deductive epistemology, right? You start with certain axioms and then you derive things out of that. So all of our mathematics is completely self-consistent. There's no room for contradiction. Now, perhaps one of the ways that it's coming up, like you said, is in the interpretation of it. What does it mean?
Okay.
And typically we are very used to, as scientists, our mathematics having a one-to-one correspondence with the things we measure in ways that we can dig in and test every single piece of that. So we are used to being able to test every bit, and it's really kind of fun. A big part of what I do as a professor is teach courses. It's not the biggest part. Most of what I do is do science. I'm a scientist, but I do get to teach a few courses. And so one of the things that that's kind of fun to watch students discover and learn is that all that math they're writing down on the page really does have a physical correspondence. Now, in quantum mechanics, it's much harder to figure out because we write down mathematics that also involves probabilities. And there's the crux, okay? We are writing down things that work, okay, where the mathematical thing is self-contained, well-defined, no logical contradictions. We can't test every piece of it. This, I think, is part of the frustration of quantum mechanics. In classical mechanics, I could test every single piece of that equation and find an experimental counterpart. In quantum mechanics, you really need to work in terms of a wave function, oftentimes. Not always, but oftentimes it's going to come to the forefront that these tiny particles don't just act like little solid balls, because they're not. They act like very fuzzy objects, and they have wave properties. They can interfere and wiggle and take on interesting shapes just like waves do. And so there's the rub. We cannot directly measure the waves in quantum mechanics. It's just a limitation of our experiments. People sometimes ask me, are we ever going to get past that limitation? We haven't gotten past it in 100 years, so I'm going to throw my hat in and say, no, I think we're stuck there. But, if someone figures out how to measure it, that's great. That'd be fantastic. So there are pieces in our self-contained, fully logical, no contradictions mathematics that we cannot directly access in the lab, namely the wave function. So that means we don't actually know if the wave function is real. Okay? We see all the evidence that the outputs of the theory, the things that we go in the lab and test, happen according to the probabilistic evolution of this wave function. They happen that way. So now you're going to find a divide among scientists who work on this. Some people say, oh, the wave function behaves in such a physical manner. I'm one of these people. I think it behaves in such a beautiful physical manner. It must be real. There must be some truth to it. And then you're going to find other people who say, well, we're really just using it as an instrument of mathematics. We can't directly test whether this piece of the mathematics corresponds to reality. And so some people say, it's just a calculation device. That's you'll find if you start reading about quantum mechanics, or especially philosophy of quantum mechanics, you'll see this lovely phrase called "shut up and calculate," which is basically, to say that it doesn't matter that we can't directly test whether this piece is real. We can still use it, and we do. And this is one of the beauties of physics, is that we don't have to know everything in order to make progress. So there are absolutely pieces in there that are untested. However, the outputs work so precisely that if any theory comes along to replace this one, it's got to have all the same outputs. So there is absolutely, there are absolutely elements of truth in there. We just can't test all the working parts.
Now, as a physicist, you're looking at the world, in my thinking at least, through the prism of mathematics.
Right.
What is that? What is math and logic and reason? How does that connect with your faith? You're not just a physicist,
right.
You're also a Christian.
Okay, so the very fact that I can apply mathematics and reason to the natural world, to me, speaks of a creator. When you were saying that we kind of look at things through the lens of mathematics, I am a theoretical physicist. And so, physics has this division of labor that's come about as the field has gotten more complicated and more advanced. We found that typically most people choose either to be theorists, that's me, or experimentalists. Theorists do math about the way the world should be. Experimentalists test the way the world actually is. Or sometimes people are observationalists, like astronomers don't get to run controlled experiments on galaxies. They just observe what actually has happened. So I'm a theorist. I am quite big on the math. At the same time, we all agree that there's some mathematical there's some logic that we use the language of mathematics to describe that logic, and that is ultimately controlling things. When we write down a law of physics, we are using the language of mathematics. Now, the very fact that I can write down laws that make sense to my human brain is totally amazing. And to me, that's evidence that somebody, whoever designed these things, wants us to figure them out, right? We could conceive of writing down laws of physics that are so complicated you would never be able to figure them out by the scientific method. You just need to throw in enough variables that are operating at the same length scales and energy scales, and it would become this Gordian knot that you couldn't untie. So I think the very fact that these knots of logic are loosely tied and we can go in and tease them out is evidence that someone wanted us to solve that puzzle. And I think that in and of itself is evidence of a creator.